Now we are going to solve the question number 4 of miscellaneous exercise chapter 1. Question number 4. So that the following 4 conditions are equivalent. Condition 1, a subset of B. 2, A minus B is equal to phi. 3, A union B is equal to B. And number 4, A intersection B is equal to A. These are the 4 conditions are to be shown as equivalent to each other, right? That means 1 implies 2, 2 implies 1. Similarly, 1 implies 3, 3 implies 1. 1 implies 4, 4 implies 1. That is how they will be equivalent to each other, because number 1 is equivalent to all of these 3, right? Then definitely they will be equivalent to each other. So no need of proving that 2 implies 3, 3 implies 2, right? We will show only 1 implies 2, 2 implies 1, and then 1 implies 3, 3 implies 1, and at last 1 implies 4, 4 implies 1 in reverse order. Okay, so first of all we will prove taking these 2, right? 1 implies 2, 2 implies 1. Okay, first let us prove 1 implies 2. So for that, let A is subset of B to show that A minus B is equal to phi. Okay, contradiction method we will apply here to prove this one. Okay, so if possible, A minus B not equal to phi. If then what will happen? A minus B not equal to phi means, what was the definition of difference of two sets? Here, if there is any element in this set, suppose X, then X must be in A but not in B. Got it? See, if A minus B contains any element, then that element must be in A, not in B, right? Suppose there is no such element that which is in A, not in B, then this will be phi, right? Here A minus B not equal to phi. That means there are some elements which are in A, that is X belongs to A and X not in B. Otherwise it will be phi, is not it? Because it is not equal to phi, that means there must be some elements in A which are in A but not in B. Okay, but this contradicts our given assumption, because if there is any element which are not in B, means that this A cannot be subset of this one, because definition of subset says that every element of A is in B, is not it? Here A subset of B means all elements of A are in B, but what are you having here now? Some elements are there in A which are not in B. That means A is not subset of B. What is contradicting our assumption? So this is contradicting our given assumption. That is A subset of B. It's contradicting this means our assumption was wrong. What was our assumption? We assumed that A minus B not equal to phi. That means if this is to be true, then this is wrong actually, right? To make this true, we have to change our mind. Okay, we cannot assume A minus B not equal to phi. That means, which implies A minus B is equal to phi. What is to be proved actually? We were to show A minus B is equal to phi. That is 1 implies 2. We have proved. Now we will show 2 implies 1. Let A minus B is equal to phi to show A is subset of B. Let X belongs to A. Then we will show logically that X belongs to B. And we know A minus B is equal to phi. Okay. You see, combining these two informations, what conclusion we can take? We cannot say anything. Okay, let me explain it. X belongs to A and we are to find A minus B. Okay, X belongs to A means A contains X this way, and B some elements are here. Okay, now you are going to find A minus B. Got it? Now, is X a member of this A minus B? That is our question, and our answer depends upon whether this X is in B or not. Okay, if X is in B, then A minus B will not contain this X here, because common elements are subtracted, isn't it? By definition, we need to write here only those elements which are in A but not in B, isn't it? Now X is in here, X is also here, then we cannot write this X, okay? But if X is not here, suppose, then X surely he will be, isn't it? If A minus B is equal to something, some elements are coming up, then can we write it as phi? No, you cannot write, because you have got some elements, isn't it? So to be phi, because we know A minus B is equal to phi, so this X must be here, isn't it? So combining these two informations, we can write that X belongs to B, which implies a subset of B. That is, we were to show, isn't it? So 2 implies 1 we got. Hence 1 implies 2 and 2 implies 1. This first one is done. Okay. Now let us prove 1 implies 3 and 3 implies. For that, first we will prove 1 implies 3. Let A subset of B. Then we have to prove A union B equal to B. For that, what is to be done? First, A union B is subset of B. This is to be shown. And next, B is subset of A union B. These two are to be shown. Then this will imply this one. So for that, let X belongs to A union B. It implies X belongs to A or X belongs to B. Case 1. Two cases are here, because X may be in this set B or here in A. So what happened in these two cases? Let's see. Case 1. If X belongs to B, then it is very interesting. If X belongs to B, then we are reaching our destination. Here X belongs to A union B, isn't it? And then those elements are in B also. So A union B, therefore A union B is subset of B. This is done. Now case 2. Let us do it by taking X belongs to A. If X belongs to A, then clearly X belongs to B. Why? How do you come to know that elements in A will be in B? Because we are given as A is subset of B. This is given. What does this mean? Every element of A is in B, is not it? So if something is there in A, so that must be in B by this definition. So in both cases, we have got A union B is subset of B. So first condition is done. Now we'll show number 2, B is subset of A union B. Let us consider Y belongs to B. Then what does this mean? Then clearly Y belongs to A union B, isn't it? Elements in union of two sets always lie in either of the two sets, is not it? Either of the two sets, right? It may be in A or may be in B. Y belongs to B means Y must be in their union. So we can write B is subset of A union B. Number 2 is also proved. Combining 1 and 2, you can say. So therefore, from 1 and 2, you can write A union B is equal to B. Got it? Now come to the last point. We'll prove 1 implies 4 and 4 implies 1. Let first A subset of B. To prove what? A intersection B is equal to A. So there again we have to prove A intersection B is subset of A subset of A intersection B. The next part you will finish by yourself. Okay, I am leaving this as a home assignment. Right? If you can't do it, then surely I will do it. Right? Okay.